Are we back to the birds? We're back to the birds?
No.
Oh, okay. Sorry.
Birds are still
We'll get to the birds. We got to make it to the birds eventually.
It's so cool. We're going in so many different ways. So, there's a colleague of mine, a physicist called Peter Fierlinger. What he does for a living is he builds very good magnetic enclosures that shield external magnetic fields. That's what he does for a living. He's in the TU Munich, the Technical University of Munich. And what happens is that what he usually does it for is he builds those very good hypomagnetic chambers, and then he puts like cold atoms, quantum experiments inside that are very sensitive to external magnetic field. So just for you to have an idea of how good his chambers are, magnetic field of your cell phone, 1 millitesla. Magnetic field of Earth, 50 microtesla. The noise level DC of his chambers, 1 nanotesla. So that's crazy. So he started hearing about like, oh, crazy magnetic field effects in biology. So here's what he did. He's a physicist, so he didn't have authorization to work with bio animals or stuff, so bio stuff. He only could work for stuff for 2 days. Here's what he did. He grew tadpoles, like new batches of tadpoles, inside those hypomagnetic field chambers under 2 conditions. And this experiment has now been reproduced in 2 other labs. Very cool stuff. In one batch of tadpoles, on top of the nanotesla residual field, they applied a tiny magnetic field on the order of the Earth, which is about 50 microtesla. Tiny, okay? But after 2 days, the tadpoles were like macroscopically okay. For the tadpoles that were grown only under the nanotesla field, about 40% of the embryos after 2 days were not viable. They were deformed. I've seen pictures. It's like crazy, like things that are where they shouldn't be. So, because the magnitude of the fields are so small, and that's why birds are extraordinary, because they can sense the magnetic fields of the Earth, right? And let me recap of what I just told you. You didn't need to apply a magnetic field. You just took out the tiny magnetic field of the Earth and you crashed with the physiology of tadpoles after 2 days. Because the field strengths are so small, if it were like a tiny magnet present in those tadpoles, right, that would be responding to the absence of the field somehow, those magnetic materials, those magnetite things would have to be huge, because only a huge magnet would respond to such small changes of field. Since those have never been observed and they would be huge in tadpoles, everyone's best guess is that this is a spin-dependent chemical reaction that is messing up somehow with embryogenesis. Other experiments done also under hypomagnetic field conditions show that the absence, taking out the magnetic field of the Earth, changes like epigenetic markers such as methylation and things like this. So this opens up like a whole new Pandora box, right? That go from like space exploration. If you want to colonize Mars, what's the magnetic field on Mars? And spoiler alert, it's way smaller than the magnetic field of the Earth. So can you colonize Mars? Can you grow lettuce in Mars? What do you need to do space farming? It's people only care about microgravity, cosmic rays. People need to start caring about magnetic fields, right? So
I would also want to know what happens if you grow the tadpoles and put a cell phone inside of this thing.
There have been experiments with ion channels. You can change the functioning of ion channels by placing a cell phone close to a culture.
Yikes.
It's like, that's both so exciting and so terrifying.
Yes, I know. So can I talk about birds? Because I'm getting to this point where I really need to tell you about all the evidence that is out there, right? So birds, again, I don't care about birds. It's way more widespread than birds. But birds. Birds, it's been known again for like 70 years that when they migrate, they use, at least as a partial cue, the magnetic field of the Earth, which again is tiny, right? How might they be doing this? In the end of the 70s, a brave theoretical biophysicist who was hailed as crazy at the time, made the outrageous at that point hypothesis. Here's what he hypothesized. Well, were this type of spin-dependent chemical reaction happening inside birds under physiological conditions, well, maybe birds could sense or respond to magnetic fields because they would be able to sense different physiological concentrations of products coming from these spin-dependent chemical reactions. Absurd hypothesis, because in order for that to work, spin superpositions would be needed to be maintained and utilized by molecules inside a cell. And the wet, warm environment of a cell actually brings things to classicality way faster than you would have, say, in a quantum computer that is at like 4 Kelvin. Right? So to this day, even though in test tube solutions at room temperature, there is no doubt that quantum stuff like superpositions are happening and are having consequences within this test tube. To this date, there is no ambiguous confirmation or refutal that superpositions can be maintained inside or let alone utilized in single cells. But let me tell you what there is. Okay? There is a lot of correlative data spanning more than 40 years, almost 50 years, that things such as whole birds, plates of cells, planaria, again, pick your organism. I can send you tables like ion channels. There's evidence that those things respond to magnetic fields in a way that is consistent with what would be expected if those behaviors were driven by independent chemical reactions under the hood. Okay? There's a lot of evidence that phenomena such as, I have a little list here because people need to understand how powerful this is. Evidence for that. Again, the evidence is correlative. There is, needless to say, I'm going to, the punchline here is that we are trying to build the experiments to unambiguously prove or refute that this is indeed quantum. But there is a lot of beautiful, the data is not super like systematic or anything, but people who say that electromagnetics in biology is not a thing, they're just out of date. It cannot be that a lot of people are this wrong. Okay? So things that have been shown to depend on magnetic fields in a way consistent with spin-dependent chemical reactions range from wound healing to DNA repair yields to cellular respiration rates, cellular glycolysis rates, metabolism working inside mitochondria. Importantly, the up and down regulation of cellular proliferation for cancer, for example, right, or for biomanufacturing. Regulation of production of ROS, stem cell regeneration, stem cell like differentiation, ion channel, cellular migration, like a cytoskeleton configuration, of oxidative phosphorylation. If one can show that oxidative phosphorylation can be controlled by magnetic fields in a deterministic way, that's huge. Methylation rates. So there's a lot of things that
from like a science fiction standpoint, we've all seen the movies where like the hero in the space movie goes into this chamber and it analyzes his health and then applies some, electromagnetic field and repairs his body. And I know this is like really far out, but it seems reasonable in some sense as well.
It's the Star Trek tricorder, right? So here's a point that I would like to make, which is important. The technology to apply the weak magnetic field strengths and frequencies that one would need is already there. You don't need big machines. You don't need like anything else. You don't need a big chamber. You don't need a big magnet. Your cell phone could do this in principle.
That's so cool. That's so cool.
But what's missing is a deterministic understanding of which magnetic fields influence, like which magnetic field frequencies and intensity influence which chemical reactions. So, for example, there is this company now valued at $9 billion called Novacure that they produce a device called Optune that treat a glioblastoma, which is a serious type of brain cancer, using what they call tumor treating fields. So basically, if you go into their documents, those are weak AC electric fields. They call it AC electric fields, which are, again, indistinguishable from a magnetic field, right? And if you go to the frequencies they utilize and the intensity they utilize, that is consistent with what would be expected if the driving mechanism for the disruption of the tumor growth was driven by a spin-dependent chemical reaction. Except that if you look at like people doing electromagnetic treatments, people using this device, nowhere is there a mechanistic understanding of what's going on. In order to do this, like, because if you don't have a way of deterministically finding this code book, well, this magnetic field does this, you're left to look for a needle in a haystack, because you can change magnetic field frequency, intensities, and that's what people have been doing over the literature for the past like 40 years, right? They say, well, a 3 millitesla, like 3 times your mobile phone at this frequency does this, and then the other people go and say, well, a DC magnetic field at this frequency does that, and there's no direct comparison, and it's all like heuristic. We need a mechanistic understanding, and my big idea here is to bring techniques borrowed from quantum instrumentation to study and control those spin degrees of freedom in biology as if they were electron spins, say, in a material. With those like big instruments that we're building, we can have hope to deterministically find like the underlying like ways that the spin is responding to magnetic fields. For the experts, just a quick parenthesis, this means like understanding the spin Hamiltonian. If we understand the spin Hamiltonian, we know exactly how each spin is tweaked in each way. And then after you build those experiments, you don't need super technology. You only need your cell phone. You only need an app where you can go and say, well, today I need help with wound healing. And then you click there and it produces the exact magnetic field intensity and frequency that you need, and then you do this.
It kind of reminds me of the early days of cancer therapy, when you would apply these like really blunt poisons to the body, and you kill off some tumor cells, but you also mess everything else up. And then obviously we're moving into these targeted therapies, different types of targeted therapies, and that seems to be definitely the future of a lot of those at least, I don't know what you want to call it, but the more destructive therapies. And I think that you can imagine something similar here, where the information landscape is too vague right now to really target what's going on.
And it's really like electromagnetics in biology as treatments, right? It's non-invasive, it's non-chemical, right? It's just like tweaking new degrees of freedom that we have been neglecting for so long. Right? It's like, it's a good thing and a bad thing. Like, if biology is really using quantum mechanics to function, our understanding of biology is radically flawed. But the opportunity is that we have the possibility of like an extra knob, of tweaking those degrees of freedom that were not known towards, for instance, therapeutics.
It seems like we might also be making a headache for ourselves in terms of policing all of the electromagnetic pollution that we have going on, if it's fair to call it pollution. You're always told, like, your 5G device poses no risk to you, blah, blah, blah. And I don't know. I've tried to dig into those topics before. I've tried to read the literature. It's very difficult to parse. There's some studies that show that there's problems. There's some that there's no problems, and it just seems like it's just a kind of an info hazard, really.
Yeah, and I think so. So here's what I would say: don't panic for the time being. So because those studies are for the time being inconclusive. It may be that only in 50 years, like when people started to smoke, right? Only in 50 years we will know if that's a problem or not. But chemical reactions that depend on spin, they only depend on very particular magnetic field intensities and frequencies. So it would really be bad luck if your cell phone manufacturer got exactly the frequency and intensity right, either to to mess up with your physiology or to improve it, right? Actually, you can also use, in principle, magnetic fields to improve your overall health.
Yeah, maybe it's just a wash, right? Maybe you're helping yourself in some ways and hurting yourself, and at the end of the day, it's just difficult to separate it out.
This makes me think of, do you know Jackie Barton?
Of course, yes.
Yeah, so
yeah, go for it. Yes, I know.
Well, I mean, just what do you work with her, or you're familiar?
No, but she you might know her because she's all about like electron transport in DNA and stuff. She showed that the yield of DNA repair in a type of bacteria is magnetic field dependent in a way consistent with this type of chemical reaction.
Exactly, and so there's all these tantalizing clues from all these different directions that people have been pointing to it from different vantage points. And it seems like what you're doing is you're really trying to say, okay, we need to codify this into a field, because when it's a field, we have a place where we can gather and we can discuss this. And that's so important. Like, I'm reading this book right now called Deep Life. And it's about
note that down. Yeah, I'm getting a lot of stuff that I'm noting down from it. Thank you. Okay,
it's such a good book. It's about the discovery of subterranean microbes in these deep mines.
Those are cool. Yeah,